represent a line in 3 dimensions? Well, it's just like representing a line in 2 dimensions, except now we have more room to wiggle, so we have more variables to take care of and sort of constraint. So what we're going to do is, let's say we have a line L that we're trying to represent. The way we're going to do it is we're going to say, look, this line L has some direction associated with it, namely V, okay? And it's got some sort of offset. It's some sort of units in some direction away from the origin. So what we're going to say is, look, I'm going to go from the origin to a certain point. Now that point is sort of arbitrary. It just has to be on the line. It doesn't matter where on the line, as long as it's on the line. I'm going to say, look, I'm going to go from the origin to that line, call it P, and then from then on, I'm going to give you the direction of the line that it's traveling in, and you can multiply it by whatever scalar you want, and you're going to be on that line. Okay? So we can represent it 2 different ways. The vector parameterization and the parametric equations. The vector parameterization is exactly what I just said. It's saying, look, I'm going to start at the origin, go to some point. Okay, so the OP is the a vector that is sort of taking care of our offset. And then add the direction of the line, V. The V is the line, the vector along the line. The direction of the line times whatever constant I want. I'll call that T. T could be negative. If it's negative, I'm going to go back from the point P. If it's positive, I'm going to go forward. Okay? So that's all that's saying. And it can be written, if you break it down, you're going to get this expression that's saying, well, it's a vector to x naught, y naught, z naught, which are just the coordinates of the point P. And then from then on, you got a vector ABC times t. ABC is just they're just the components of V. Okay? So if we want to break them down up into components, write the x component and the y component and the z component by themselves, we'll get what's called the parametric equations. This set of equations, the 3 equations, are exactly the same thing as this, except broken up, right? Because what this is saying is, look, my line L is going to be x naught plus at. Actually, the x component of L will be x naught plus at, and that's exactly what this is saying. And the same thing for y and the z components. So there you have it. It's very easy, and there's no need to get tripped up over the details.